Hey everyone, welcome back to AI Explained Simply. Today we're diving into one of the most exciting topics in AI, fine-tuning large language models, or LLMs for short. Now, I know what you're thinking. That sounds super complicated, but stick with me, because by the end of this video, you'll understand exactly what fine-tuning is, why it's so powerful, and how it works. Think of it like this. Imagine you have a really smart friend who knows a lot about everything, but you want to teach them to be an expert in your favorite video game. That's basically what fine-tuning is. Taking an already smart AI and making it really, really good at one specific thing. Today we'll cover what exactly is fine-tuning and why do we need it, the different types of fine-tuning, how the process actually works, real-world examples you see every day, and some fascinating insights about the future of AI. So grab your notebook and let's get started. What is fine-tuning? All right, let's start with the basics. What exactly is an LLM? Large language model. That's our LLM. Think of it as a super smart computer program that learned to understand and generate human language by reading basically the entire internet. Models like GPT, ChatGPT, Claude, or Llama, they're all LLMs. These models are incredibly smart, but here's the thing, they're generalists. It is like having a friend who's decent at every school subject but isn't amazing at any one thing. Fine-tuning is the process of taking this general-purpose AI and training it further on specific data to make it excel at a particular task. Think about it like this. Imagine you're a good overall student with B+ grades in everything. Now, if you spend extra time studying just math with a specialized tutor, using math-specific practice problems, you could become an A+ math student. That's fine-tuning. The original LLM is our B+ student, and fine-tuning is that specialized tutoring session. Let me introduce some key terms we'll use. Base model. That's the original pre-trained LLM, our B+ student. Training data. The specialized information we use to teach our model. Parameters. Think of these as the brain cells of our AI, numbers that determine how it responds. And epochs. How many times we show the model our training data, like studying the same material multiple times. Here's a quick example. If I ask a general AI, how do I fix a leaky faucet? I might get a decent general answer. But if I fine-tune that same AI on plumbing manuals and tutorials, it could give me step-by-step instructions with specific part numbers and tools needed. Why do we need fine-tuning? So why can't we just use the base models? Great question. There are several reasons. Reason number 1, specialization. General models are jack of all trades but master of none. If you're building a medical diagnosis AI, you want it to be incredible at medical stuff. Not just pretty good at everything, including cooking recipes. Reason number 2, your specific data. Maybe you have a company with specific terminology, or you're working with a language that wasn't well represented in the original training data. Fine-tuning lets you teach the AI your specific language. Reason number 3, control and safety. When you fine-tune, you have much more control over how the AI behaves. You can make it more helpful, more accurate, or follow specific guidelines. Reason number 4, cost and speed. Smaller fine-tuned models can often perform better than huge general models for specific tasks, while being faster and cheaper to run. Let me show you some real examples. Customer service bot. A general AI might give generic responses like, please contact support. But a fine-tuned AI knows your company's specific products, policies, and can say things like, for your Model X200 printer, the toner cartridge part number is TC45B, and you can order it directly through our portal. Creative writing assistant. A general AI writes okay stories, but a fine-tuned AI can write in the style of your favorite author or genre. Imagine an AI that writes exactly like Stephen King or Jane Austen. Code helper. General AI knows programming basics and might suggest generic solutions. But a fine-tuned AI knows your company's coding standards and can work with your specific frameworks, suggesting code that fits perfectly with your existing codebase. Now that we know why we fine-tune, let's talk about how. Types of fine-tuning. Not all fine-tuning is created equal. There are several different approaches, and choosing the right one is super important. Full fine-tuning. The traditional approach. This is like taking our student and having them retake all their classes with new specialized materials. We update every single parameter in the model. The pros are maximum customization and best performance for specific tasks. The cons are that it's expensive, requires lots of data and computing power, and takes a long time. Then we have parameter-efficient fine-tuning, or PEFT. This is the smart, modern approach. Instead of retraining everything, we add small adapter modules or only update specific parts of the model. Think of it like this. Instead of rebuilding your entire computer, you just add a graphics card for gaming. Much cheaper and faster. There are popular PEFT methods. LoRa, low-rank adaptation. This is the rockstar method right now. We add small adapter layers that learn the new task while the original model stays frozen. It's like giving our student a specialized notebook for each subject. Adapters. Similar idea, different implementation. These are small modules inserted between existing layers. Think of them as translators that help the model understand new concepts. Prompt tuning. We don't change the model at all. Instead, we learn the perfect way to ask the model questions, like learning exactly how to phrase questions to get the best answers from your teacher. Here's the trade-off. Full fine-tuning gives you maximum control, but costs the most. PEFT methods are much more practical for most people and still give great results. How fine-tuning actually works. All right, let's walk through how fine-tuning actually works behind the scenes. Don't worry, I'll explain it in simple terms. Step 1. Choose your base model. You pick your starting point. It's like choosing which type of student you want to tutor. Are they already good at language, math, science? Step 2. Prepare your data. This is crucial and often the hardest part. Your data needs to be high quality with accurate, well-written examples. It needs to be relevant and directly related to your target task. It must be consistent with the same format and style throughout. And you need sufficient data, usually thousands of examples minimum. Think of it like creating the perfect study materials for your tutoring session. Step 3. Set your settings. These are called hyperparameters. Learning rate determines how fast the model learns. Too fast equals chaos. Too slow equals barely any improvement. Batch size is how many examples to show at once. Epochs is how many times to go through all your data. Think of these like oven settings. Temperature, how much food you cook at once, and how long you cook it. Step 4. The training process. This is where the magic happens. The computer shows your model thousands of examples and slowly adjusts those parameters we talked about earlier. It's like flashcards, but for AI. The model sees an example, makes a prediction, gets told if it's right or wrong, and adjusts its brain slightly to do better next time. Step 5. Testing and evaluation. After training, we test our model. Does it perform better on our specific task? Did we accidentally make it worse at other things? Is it giving consistent, reliable answers? Real-world examples. Let me show you some amazing real-world examples of fine-tuning that you might not realize you're already using. Netflix recommendations. Netflix doesn't just use a general recommendation AI. They fine-tune their models on your specific viewing history, the time you watch, what you skip, what you binge watch. That's why Netflix seems to know you better than you know yourself. Google search. When you search for something, Google isn't just using a general search algorithm. They fine-tune their models based on your location, your search history, what others in your area are searching for. That's why your search results are different from someone in another country. Spotify Discover Weekly. Spotify fine-tunes their music recommendation models on your listening patterns. What you skip, what you replay, even what time of day you listen to different genres. It's like having a DJ who knows your exact taste in music. Social media feeds, Facebook, Instagram, TikTok, they all fine-tune their content recommendation models specifically for you. They learn what makes you scroll, what makes you engage, what keeps you on the platform longer. Voice assistants. Siri, Alexa, Google Assistant get better at understanding your voice specifically. They fine-tune on your accent, your speech patterns, the words you commonly use. Even autocorrect on your phone fine-tunes to your writing style. It learns the words you use most often, your common typos, even your slang. These are all examples of AI that started as general-purpose models, but were fine-tuned to work specifically for you. The future of fine-tuning. So what does the future hold for fine-tuning? It's absolutely fascinating. We're moving toward a world of hyper-personalized AI. Imagine having an AI assistant that's fine-tuned specifically for you. It knows your communication style, your preferences, your work patterns, your goals. It's like having a personal assistant who's worked with you for years and knows exactly how you think. We're also seeing the rise of domain-specific AIs. Instead of one giant AI trying to do everything, we'll have specialized AIs for medicine, law, education, creativity, each fine-tuned to be absolutely exceptional in their specific field. Real-time fine-tuning is becoming possible. Instead of training a model once and using it forever, AI models will continuously learn and adapt in real time based on new information and feedback. Collaborative fine-tuning is emerging where multiple organizations can contribute to fine-tuning a model without sharing their private data. It's like having multiple teachers contribute to tutoring a student without revealing their teaching secrets to each other. And here's the really exciting part. Fine-tuning is becoming accessible to everyone. You don't need to be a tech giant or have millions of dollars. Small businesses, individual creators, even students can fine-tune AI models for their specific needs. Common misconceptions. Before we wrap up, let me clear up some common misconceptions about fine-tuning. Misconception number 1. Fine-tuning is just for tech experts. Wrong. Modern tools are making fine-tuning accessible to anyone willing to learn. You don't need a PhD in computer science. Misconception number 2. You need massive amounts of data. Not true. While more data can help, you can achieve great results with hundreds or thousands of examples, not millions. Misconception number 3. Fine-tuned models are always better. Actually, sometimes a general model works just fine for your needs. Fine-tuning is powerful, but it's not always necessary. Misconception number 4. Fine-tuning is expensive. With modern efficient methods like Llama, you can fine-tune models for the cost of a coffee. The expensive days are behind us. Misconception number 5. Fine-tuning ruins the original model. Modern techniques preserve the general knowledge while adding specialization. It's additive, not destructive. So what are the key takeaways? And there you have it. We've covered everything about fine-tuning large language models. Let's quickly recap the key takeaways. Fine-tuning transforms general AI into specialized experts, just like turning a B+ student into an A+ specialist. Modern methods make it accessible and affordable for everyone. It's already everywhere in your daily life, from Netflix to Google to your phone's autocorrect. The future holds hyper-personalized AI fine-tuned specifically for you. The most important thing to remember is this. Fine-tuning isn't magic. It's specialized education for AI. Just like how you might study extra hard for your favorite subject and become really good at it, we can teach AI to become really good at specific tasks. Whether you're a student, a business owner, a creator, or just someone curious about AI, understanding fine-tuning helps you understand how AI really works and how it's going to shape our future. If this video helped you understand fine-tuning, hit that like button and subscribe for more AI explanations made simple. I read every comment, so let me know. What would you fine-tune an AI to help you with? Next week, we'll be exploring how AI actually learns and remembers information. You won't want to miss it. Thanks for watching. And remember, AI isn't magic. It's just really, really smart tutoring.